research options in sustainability of groundwater sources. I am happy to introduce our speaker for this session, Dr. T. Subramani sir, Professor and Head Department of Geology and Mining Engineering, Anna University. His expertise is in the field of geological engineering, geospatial technology, hydrogeology, mining geology, environmental engineering, and engineering geology. Sir was awarded the Young Scientist Award by the Department of Science and Technology and Wenlock Endowment Award for Best Research Publication by College of Engineering, Guindy. Today, sir will be enlightening us on the topic Sustainable Groundwater Development Research Opportunities and Challenges. Over to you, sir.
Good afternoon to all of you. So at the outset, I would like to thank the organizers for giving me this opportunity to interact with you on this particular topic, Sustainable Groundwater Development, Research Opportunities and Challenges. So I think you need not take snaps because the entire thing is recorded. So maybe after 1 week, all the talks will be available in the CFR, Center for Research website. And of course, these slides will be available in the form of PDF. So you can download. So before getting into this topic, I would like to tell the facilities available in our department. So in the Department of Geology, we have excellent facilities for groundwater research. So you name any equipment related to water quality or groundwater, yes, we have. Say for example, very recently we have purchased this instrument called ICPMS. So the cost of the instrument is nearly 1 crore. So you can analyze the water samples, groundwater samples. So under DST FIST program we have purchased this. And we have other sophisticated instruments like AAS, then total TOC, total organic carbon. We have IC, ion chromatography, particle size analyzer, SEM, then microscopes. So these microscopes will be very much useful to identify microplastics in water or groundwater samples. So like that we have even resistivity imaging system, we have GPR, ground penetrating radars. So we have lot of facilities in our department. Then of course this groundwater research is concerned. So we have published lot of papers. Of course we have edited lot of books related to groundwater. So we have edited so many books. Then we have edited so many journal volumes. Of course, I have edited 5 journal volumes. So you can see the journals. So geochemistry, elsewhere, marine pollution bulletin. Then these 2 related to groundwater quality. So now at present I am editing 4 journals. Of course, all the journals are falling in the Q1 category with a high impact factor. So you can publish your research. Then if you see the publications in the last 5 years, so we have published so many papers, but if you see the high impact factor papers, so we have 26 papers in the last 5 years with the maximum impact factor of 14, and of course you can see the journals also. So Elsevier and Springer, Taylor and Flatsey. So we are regularly publishing a lot of papers in leading journals, international journals. So you can see the papers. All are related to groundwater only. So starting from Journal of Hazardous Material, so you can see the journals. And of course not only in Elsevier and Springer, so some of our papers were published in Nature also. Of course this first paper is not related to groundwater. Of course this paper was published in the year 2014. At the time the impact factor of the journal was 47. I think this is the one and only paper available in the entire Anna University. Even I think in IIT also this Nature paper is not available. Then of course second paper of course very recently published in Nature, Scientific Data. Then our research will frequently come in the media, newspapers. Then very recently we got patent also. One patent I got patent for this, designing the water quality equipment. Then this patent was awarded to Professor Ilango and his team for recharge mechanism. So how to make the artificial recharge. So already explained by our regional director, Dr. Sivakumar. He is really a good storyteller. I told him he's a really like a teacher he is really eligible to become a teacher. Maybe I requested him after his retirement, he has to come to this profession. So because good teacher should be a good storyteller. Right. So this one, say how to improve the groundwater recharge. So for that, we have to provide ventilation. Okay, we have to provide ventilation, so then only the water will easily percolate into the subsurface. So for that, we got patent. So 20 years patent was very recently granted. Then of course, many foreign scientists foreign research scholars are very frequently they are coming to our department. Many students are coming to our department and they are doing some kind of research. Then our students are frequently visiting other universities. Foreign universities, they are very frequently visiting so many countries, Italy, Sweden, France, German. So we have friends there. So we have international collaborations. Very frequently they are going there and doing some part of research work there, and we will publish, we will make collaborative publications. Then one more important thing I want to tell this one. So very recently this has been published. So this company, this company has conducted a survey. So they have collected the published papers of the past 10 years from 2013 to 2023 all over the world, and they have given ranks. So fortunately, myself and my student got first 2 places in India. So in India, myself and my student got first 2 places in the groundwater research. So my student, Dr. Karnanidhi, is working in Hindustan Engineering College, Coimbatore. So unfortunately, today he didn't come here. So we concentrated more on health risk evaluation. So here they have taken 24 papers, my 24 papers for this particular award. So almost all the papers are related to this one. Some component will be there related to the human health risk evaluation. So I'll tell you the importance of this. This is one of the important areas where you can concentrate, because most of the people are not working in this particular area. It's a new area, I can tell. Then coming to this about our subject. So already in the inaugural function, Madam was telling about the water vision. Water vision. So Vision India, in this vision, Vision India 2047, this water vision is very, very important. So we are giving lot of weightage, not only in this, even in G20 also, this importance for water is given. So in the SGD, morning they were telling about, our Vice Chancellor was telling about SDG 6. So SDG 6 is nothing but mining, clean water and sanitation. So water is always there. So we have to provide clean water. That is one of the important goal, sustainable development goal. Yes, when you talk about this sustainability, so we have to consider all these things. See, environmental protection, then mitigation of water related hazards, then resource conservation. So conservation is also very important. Then social responsibility, long-term sustainability, compliance with regulations, then best practice we have to follow, then transparency, then finally climate change and mitigation. So these are all the important things when you talk about sustainability of groundwater. So because morning the speakers, they have addressed about artificial recharge, water quality, management. So I don't want to repeat those things. So that is why I have put some case studies related to mining and other things. So this is one of the important area. Now the mining industry is growing like anything, particularly after this Russia-Ukraine war. So we need material for the industry, particularly RE, rare earth. So mining activity is going on well. So we cannot stop this mining activity. Definitely this mining activity will have some impact on the groundwater system, but you cannot stop mining. So people will simply say, why you have to mine? So if you stop this mining industry, you must close all other industries, including agricultural industry. No other industry can exist if you close this mining industry, because so this is the industry giving raw material to the other industries. So whatever the material you tell, everything is taken from our earth. So this, we cannot stop the mining industry. Then one important thing I want to tell you before getting into the mines. So very recently, so this Anna University was given this particular thing, See, sustainability star rating for minor minerals in Tamil Nadu. We are the authority to award star rating for the granite quarries in Tamil Nadu. So this is the first time in India. Of course, in India, there are two more central government agencies. So one is Ministry of Mines, Indian Bureau of Mines. It may give ranking for the mines. Then second one is Coal India. Coal India will give rating. Like say air conditioner, some stars will be there, 3 stars will be there, 4 stars will be there. So similar to that, so we are going to award star ratings for the mines, particularly granite mines or granite quarries in Tamil Nadu. So this was given by the Ministry of Environment, Forest and Climate Change. So very recently this was approved by our Vice Chancellor. We are going to implement this particular thing. So here why I am telling this, is in this sustainable star rating, groundwater is one of the important components. So without considering groundwater, some of the mines will be going below the groundwater table. So of course they are withdrawing water, they are depressurizing the aquifer in some cases. And of course because of that, see, your groundwater is also getting polluted. So this groundwater is one of the important components in this system, in the sustainability star rating. Then next proposal, of course, we have submitted to the Ministry of Environment and Forest. So what are all the impacts that can happen if you remove a particular hill? For example, this stone quarry is very common now in Tamil Nadu, not only in Tamil Nadu. Say after this M sand. So previously for construction we are using river sand. Now river sand is not available, so everybody is using M sand. So what is M sand? It's nothing but rocks. So we have to crush the rocks and we have to get the sand. So because of that, so what will happen? So we will be losing some of the hills. So நம்ம படத்தில் பார்த்துருப்பீங்க, வடிவேல் சொன்ன மாதிரி கிணற காணோம் அப்படின்னு சொல்லுவாங்க. இப்போ பார்த்தீங்கன்னா நிறைய பெரிய மலையே காணாமல் போயிடும். நீங்கள் ரோட்டில் போகும்போது பார்த்துருப்பீங்க, பெரிய பெரிய ஹில்லே காணாமல் போயிடும். Definitely some environmental impact will be there. ஸோ வெறும் ஹில்லை காணாமல் போகிறது மட்டும் இல்லை, there will be lot of issues. அதுலேருந்து ட்ரைனேஜ் காணாமல் போயிருக்கும், அங்கேருந்து வெஜிடேஷன் காணாமல் போயிருக்கும். ஸோ land use is completely getting changed. So we have to study the impact. So for that purpose we submitted proposal. Of course we got green signal. We have to do this work. Of course already we have given some kind of project to mining engineering students and also geology students. They have taken Krishnagiri area and also Tirupur, Coimbatore area, and they started working. They have started preparing various thematic maps pertaining to this particular study to know the environmental impact due to the removal of hills. Then I will present some case studies. Very recently, of course, we got one project from Dalmia. So this is in Ariyalur area. So they have mines. Now they want to expand the mines laterally as well as vertically. So what will happen if they expand the mines vertically? Definitely they will puncture the groundwater table. They will go below the water table. So because of that, what will happen? Groundwater quality is affected. Groundwater quantity is also affected. So if they want to get clearance, easy clearance, definitely they have to address this groundwater issues. In addition to the other mining related aspects like slope stability and other things. So they must address this groundwater issue in this particular area. So for that purpose, we have taken up this work and we have done some kind of work. So we have created this buffer zone around this particular area, and we have created this contour map. We have generated contours, ground elevation contours. Then we have prepared a 3-dimensional digital elevation model of the area. Then here you can see the minimum elevation, maximum elevation. And of course, one important thing we must know, this limestone is a non-renewable material. It is not renewable. Groundwater is renewable, fortunately. If today groundwater is not available, tomorrow it is possible to recharge. But if you exhaust this limestone, it will take millions and millions of years to form. This limestone, if you see the age of this limestone, it is about 65 million years. This limestone has formed when the dinosaurs were living in the earth, 65 million years back. So at the time Ariyalur was, sea was at Ariyalur. So at the time these deposits have resulted. So if you exhaust this limestone, definitely you will not get back. So this is a major problem. So we should be very careful while mining the deposits. So for that purpose, what we are doing, we are suggesting so many other things also to reduce the consumption of limestone or cement. For example, if you want to construct building, all the walls are made up of cements. cement blocks, or we are using bricks. To avoid that, so columns and beams can be concrete, and remaining thing maybe we can use some kind of wooden material like in foreign countries people are using, so that we can reduce the consumption of cement. Like that we have to give proper suggestions to the government, so then only we can save this. Then we analyze about the drainage pattern, stream orders, drainage pattern, how these drainages are getting affected in this particular area. Then finally we have to provide the solution. What is the remedy for this? We cannot stop mining activity, so we have to go further. So these are all the remedies. So we have suggested the places where we have to do artificial recharging. So artificially we have to recharge the groundwater. So morning Dr. Sivakumar sir was telling about this. So you have to create these kind of trenches or pits or ponds, wells. So artificially we have to recharge the groundwater system. So because in the mines they are continuously pumping out water. Continuously they are pumping out water. Even if you take NLC, Neyveli, so it is actually a confined aquifer. So they have drilled so many wells around the mines and they are continuously pumping out water. So you have to depressurize the aquifer, then only the mining activity will take place. Otherwise you cannot do mining. So here also they are going below the water table. So obviously they have to do this one. So they are withdrawing more amount of groundwater, they have to recharge. So we have suggested them to do this, then only of course they will get clearance. Here, in addition to that, we have tested the quality of the water also. And of course they have created this kind of pond in afforestation area. So they are growing number of trees, particularly native species, like a neem tree. They are growing number of trees around the mines. These are all very important. Then next important is one part. Mining is one part. So the next important area where you can concentrate is research in this field. Microplastics in groundwater is another major area. So microplastic pollution in groundwater. So for that, what we have done, we have collected a lot of published papers. So here my student is there, Mr. Prapanjan is there. He has collected 241 papers published in various international journals. So he has downloaded 241 papers, and from that, finally we have published this review paper. So another CLRI scientist is also there, she is working with us. So Dr. Satya. So we published this paper after studying all the 241 papers, international papers. So of course when you talk about microplastics, again the problem is there is no standard for this. So here see, if the size is less than say 5 mm, generally the plastic is called microplastic, generally. But you know, the different scientists are viewing in a different way. So of course these terms are also used in this field, nanoplastics, or this microplastics, mesoplastics and macroplastics. Now the water samples are containing some amount of microplastics. So it's a major threat, a very important area where you can work. Yeah, in different forms, it is available in different forms. You can see like micro beads, pellets, film, fiber, fragments, you can see based on the size and shape. So we have different categories. So these are all available in the water. Then of course we have well established methodology to identify the microplastics in water. So we have excellent methods. For example, how to find out microplastics, availability of microplastics in sediments. Yes, we have method. So microplastics in water, how to detect microplastics in water. So how to find out microplastics in salt. So now we are planning to test even all the commercial drinks, whether all the commercial drinks are containing microplastics or not, like Pepsi, Coca-Cola or Maaza. So we have to test. So this is the standard methodology available to find out the availability of microplastics in sediments, water and salts. Then coming to the health risk assessment, so this microplastic is entering into our system directly or indirectly. So through water, we are consuming water. So this microplastic is entering into our system, and now it is available in our bloods. Definitely if you test your blood for microplastics, definitely some microplastic or nanoplastic particle will be there. Definitely it will be there. So it is already proved. Okay. So this is the scenario. So another important thing is, as I have mentioned already, there is no standard available for this. No standard will talk about microplastics. For example, if you take a WHO standard or BAS, Indian standard, so you can see the limits. So what is the maximum allowable limit? What is the desirable limit? So if fluoride is more than 1.5 milligram per liter, we should not supposed to consume the water. Like that you have limits. But for this microplastic, nothing is available. You people should create. We have to do research and we have to do that. Then similarly, health impacts, we do not know. We have to still depend on the doctors. So what will happen if microplastics enter into our system? If it is available in our blood, what will happen? What kind of disease it is going to create? Again, it's a very big question mark, but definitely some impact will be there. So not only these microplastics are available in water, but also it is available in plants, also available in say cow milk, it is also available in fishes. So this is the pathetic thing. So simply we are using water bottles and we are throwing. So these plastics are creating lot of issues, right? Not only in the water related environment, it is polluting soil, air, because they are burning the waste, no? So they are burning the plastics also. It is polluting land, it is polluting soil, it is polluting aquatic system. So we must be very, very careful about this. This is a dangerous pollutant. Silently, it is getting into the water. So we must be very careful. So we have done some excellent work. We have published in very leading journals. I will show you. Yeah, this is about the distribution of microplastics worldwide. Of course, here you can see you have a lot of microplastics. Then polymer types. So when you say microplastic, when you say plastic, in plastic you have different types. So polyester or polyethylene, like that we have different categories. So this can be very easily identified with the help of FTR. I will show you that. Then after that, what we have done, I have given this work as a kind of PG project. So our students have collected 44 water samples from 44 lakes in Chennai city, Chennai and surrounding area. So they have collected water samples from 44 lakes. So unfortunately, all the 44 lakes are having microplastics. This is the scenario. All the lakes are having microplastics. So these are all the lakes where we have collected samples in Chennai and surrounding area. Maybe the content may vary, quantity may vary, but all the lakes are having microplastics. And another important finding in this thing is the lakes which are away from Chennai, if you go away from Chennai, the content of microplastics are more when compared with the lakes in cities. So reason is, frequently we are removing the microplastics in cities, but in rural areas what they will do? They are not removing the microplastics. In Chennai we are frequently collecting and we are disposing in one particular place, but in the village areas, if you go away from Chennai city, then the number of microplastics in water samples are more. Then you can see the photos, micro photos. So photos taken using microscopes. So I told you microscopes are very important to take these kind of things. You can see the different shapes and size, different shapes, different size. And of course you can confirm, there are some tests sometimes to confirm whether this is microplastic or not. What you will do, they will go for a hot needle test. If you have a hot needle and if you touch that microplastic, if it is a plastic, it will melt, isn't it? So like that you have to confirm. So before counting, so you can simply count. If you take 1 liter of water, what you have to do is you have to filter the water, then you have to take the filter paper, and filter paper should be kept under microscope, and you have to view through the microscope, and you can count. You can count and you can identify the what type of microplastic it is. You can very easily identify. Yeah, here also. This is in sediments and this one is in water, lake water, freshwater lakes. Then I told you about this FTIR, IR spectrum. If you use that, you can identify what type of plastic it is. So you can, to identify to classify the plastic, you have to do this. Of course, this facility is available, of course, in many, even chemistry lab or physics lab, these kind of facilities are available. So you can confirm this. Now you can see the count. So even in some lakes, you see it crosses 100. More than 100 microplastics are there in 1 liter of water. So this is the present scenario. Then we have extended our study to the salt water, salt pans, and also the coastal aquifers. So we have published very recently this paper in Taylor and Francis, Human Ecological Risk Assessment Journal. So in this, we have taken this stretch, Mahabalipuram to Ennur. So we have collected seawater, we have collected well water, we have collected sediments, we have collected salt from salt pans, and we have tested whether these things are containing microplastics or not. Yeah, again we found lot of microplastics in all, sediment, seawater, shallow groundwater, and also in salt pans. So you can see the color also, different colors, white, blue, black. So you can see the different colors also. Yeah, this is the distribution. Of course, this is a land use map of the coastal area. We have prepared using satellite image. Then you can see the microplastic count in water. So they have prepared this diagram. This is published in that particular journal. Then I told you about salt pan. So we have collected samples in the salt pan near Muttukadu coast. Of course, this place is famous for boating. Very close to that, we have salt pans. So we have collected 10 samples. So all the 10 samples are having microplastics. So we have collected samples, and you can see the statistics. So all the 10 samples are having microplastics. So we are taking that salt. So this is the scenario. Yeah, you can see this count. This one is count at 10 locations, and this one is based on the color. Based on the color, how many white microplastics are there, green, red, black, blue. So all those things. So the main source for this microplastic is mostly nets. Fishermen, they are using nets. No? So that may be the major source, we think. Yeah, the next important area where you can do research in the groundwater field, I think nobody is working in this particular area. So we have started, first time in India, so we have started this work in the year 2019, particularly during the corona pandemic. So we have done a lot of work on this human health risk evaluation, and we have published a lot of papers. Lot of papers we have published in this. And of course, few scientists in US, China, so they are doing a lot of work on this. I will tell you the importance of this health risk evaluation. So this, here we are not simply comparing our water quality with the existing standard. Normally what we will do, so we will simply compare the water quality parameters with the existing standards. So I told you, if it is a fluoride, it should be less than 1.5. If it is more than 1.5, it is not suitable for drinking. So TDS means 1500. Like that, even nitrate 45 milligram per liter. So this is one step beyond that. This is one step beyond that. So only in the research level, in the university level, we are doing this kind of research. So here I'll give you some case studies. So this one, we have collected groundwater samples from Tirupur area. Of course, this famous area is called Tex Valley, and we have studied the groundwater. We have analyzed this groundwater and published long back in the year 2021 in the journal, one of the important or leading journal called Chemosphere. So at the time, impact factor was 7.1. So in this journal, one beautiful thing is graphical abstract. In most of the journals, you cannot see the graphical abstract, but here you can see the graphical abstract. This will give the complete picture about this particular paper, what kind of work has done in this particular area. So here you can see what are all the sources for nitrate. So here you can see the sources. Then what happens? You are taking out the water from open well or bore well. You are using the water for bathing. Then you are consuming the water, drinking the water. So again, this sample is taken and we have tested in the laboratory for various parameters. And so we have calculated this HQ, hazard quotient, for oral pathway and also for thermal pathway. Then put together it is called THI, total hazard index. So we have to find out total hazard. I'll tell you how to find out. Then finally we have to suggest some remedial measures. How to minimize this. We cannot control, we cannot stop 100%, how to minimize this. Then, so we have to prepare these kind of schematic diagrams to explain. So what is going on in that area? Say for example, you can see the sources. There are different sources, okay, for nitrate contribution. So here you have this aquifer and you are taking out the water. Then I have related this with a hydrological cycle or water cycle. Yeah, then we concentrated on fluoride also. The previous one was related to nitrate and this one is related to fluoride. We published in the journal RSC. Yeah, this one, yeah, how to compute health risk. So these are all the formula you can use. So we have to consider so many parameters and age group wise you can find out. So for different age group of people, what about children, what about men, what about women? So what kind of risk they will be having if they consume this type of water. Then, yeah, this one is, say if THI, total hazard index is less than 1, then it is safe. If it is more than 1, it poses risk. So here, this is the line. So these are all the samples having a risk. But definitely you can see in the field also. So this dental fluorosis will be there. Even skeletal fluorosis will also be there if the concentration of fluoride is more. Not only concentration is one of the parameters in this calculation. So we have to consider the other things also. For example, how much quantity of water you are consuming. This is also another important thing. So body weight is also another important thing. So like that, there are so many parameters we have to consider. Yeah, age-wise, what happens? So we have to do this kind of research. This is another area where you can work. Then next one, of course, this study we have carried out in Sivagasi area because of this fireworks. So this groundwater is polluted with perchlorate. There is a substance, chemical substance called perchlorate. So this is also polluting the groundwater. Of course, we have collected samples in this area and this is the area where the perchlorate concentration is more. And finally, we made a conclusion that if you take the top aquifer, where most of the bore wells are located, open wells are located. So here the concentration of perchlorate is more, not suitable for drinking. But fortunately, the lower aquifer or the deeper aquifer is having less amount of perchlorate. So we have suggested to the village administration, VAO, please don't provide this water for drinking. You better use borewell water for drinking purpose. So this we can do. Then next important area, of course, morning regional director was telling about radioactivity. So this radiation in groundwater, this is another area where you can work. Even most of the people are not working in this radiation in groundwater. So Sir was telling about this Krishnagiri area where the radiation level is high. Radiation level is high. Of course, we have done some kind of research in Tirupattur area. I'll tell you that. So this is actually Tirupattur area, is very close to Yelagiri. So there is a place called Sevatur. Sevatur, this is the Yelagiri hill and this is Sevatur. So we have carried out research in Sevatur area and of course now one student is doing in this area, Samalpatti area, where the rocks are having lot of radioactive minerals. Rocks and soil, we have lot of radioactive minerals. And of course, here there is a mine. Here there is a mine, is actually a vermiculite mine. Vermiculite is a kind of mica. Of course, it's a government mine, TAMIN. So I am also director for the TAMIN, Tamil Nadu Mines, Tamil Nadu Minerals. So we cannot stop this mining activity. This is an important material which is used in electrical industry. It's the best insulator. It will not conduct heat. It will not conduct electricity. So it's an important material. We cannot stop mining. Of course, in this area, in the rocks, we have lot of radioactive minerals and other important materials. Definitely in future, so Geological Survey of India will explore more and they may start mining all these things. Because there is a huge demand for RE, rare earth elements. So that is why people are sending lot of, say, satellites and other things to the moon. Because you all know that in moon we cannot live. Am I right? There is no possibility to live in moon. Because there is no atmosphere. So there is no possibility. Then why people are sending, say, landers and rovers to moon? Mainly, what kind of material is available? What kind of RE is available? Whether is it possible to do mining there? Then is it possible to bring back the material from moon? For that purpose, research is going on, mainly. So here we have a lot of rare earth elements And in addition to that, so as I mentioned, no research work is being carried out in this particular area, in this concept. Radiation in groundwater. Radiation in groundwater now is another important parameter you have to include in the water quality. Water quality parameter. This is also another important water quality parameter now. So for that purpose, of course, they have taken the entire basin, Pambar river basin. This is called Pambar river basin. And they have prepared so many maps, thematic maps. Then finally, we have taken a small area for detailed study. This is a small area, and we have collected a lot of samples. And of course, we have done geophysical survey also. The mining students, they are doing geophysical survey there to know about the aquifers and other things. Then we have used this instrument, this is called scintillometer, gamma ray scintillometer, to find out the radiation. Okay, then we have used this also for gamma and beta measurement. We have used this instrument. Of course, you can see the impact because of fluoride. Yeah, radiation, this is the values in microrangens per hour. So radiation in geological formations, particularly in rocks and soils. Then this is the important mineral which is giving radiation. This is called pyrochlore. This is a niobium based mineral. It is available in the formation. Of course, we have superimposed the radiation contour over the geological map of the area. Then of course here we have collected water samples, and we have measured the in situ parameters, and we have collected water from duck wells, bore wells, hand pumps. We have included all, and you can see the important parameters: electrical conductivity, TDS, salinity, and other things. Then of course fluoride is also high at some places. Fluoride is also high at some places, and this is the mineral which contributes fluoride to the groundwater. It is nothing but the apatite. It is nothing but fluoroapatite. It is available like a crystal. You can see how big it is. So it is releasing fluoride ion to the groundwater system. Of course, for fluoride we have done the health risk assessment. Yeah, this is the output we got: HQ oral, HQ dermal, and DHI. So based on this, so 37%, 14%, and 17% of the samples are possessing risk for children, women, and men respectively. So children are more vulnerable than women and men. So this is the scenario there. Of course, very recently I have given a talk to the scientists in China. One of my friend Lee has asked me, generally risk will be more for this one. This is men. When compared with women and men will have less risk when compared with women. In most of the cases we will get the result like that, but here it is totally different. It is slightly different. So men are more vulnerable there than women. He asked me what is the reason for that, because we are not getting this kind of results there in China. I told, because in this area, so this men are going for various construction and other mining related works. So they are consuming more water than women. So that is why the risk is more for men when compared with the women. So this is the scenario there. Then you see the radiation in water. See, these are all the samples possessing more radiation. So this uranium content in ppb, parts per billion. So D means duck well, open well. B means bore well. H means hand pump. You see, there is a hand pump which is having the maximum radiation of 300 plus. Somewhere you can see the value. So of course this water is being continuously used by the people. I'll show you that. Yeah. Here you can see. So this bore well. Yeah. So as per this standard, WHO standard, so uranium concentration should not be more than 30 ppb. So this is the standard. So if it is more than ppb, you should not supposed to consume the water. So as per this AERB, Atomic Energy Regulatory Board, so they have fixed the limit as 60. At any case, this value should not be more than 60, right? So many samples are having more uranium concentration in groundwater. So this is the area where you can concentrate. Then next one, I'll tell you morning Regional director was telling about artificial recharge. I don't want to go deep into this because you know about artificial recharge. So there are different structures we have to construct. You have to identify the right place and you have to choose the right structure for injecting the water. So morning he was telling about the collection of this rainwater. So very recently during this COVID pandemic time, so I have constructed a house at Tiruchengodu where I have created a huge sump to store 36,000 liters of water. So you should also do that. Okay, you can store the water which is falling on the roof, you can store it and you can use it for at least for gardening. If not for drinking, at least you can use it for gardening. So you can reduce the withdrawal of groundwater for various needs. So it's very, very important. Of course, this is a Bhavani area, a lower Bhavani area. So before suggesting new structures, so you must study the existing structures. What are all the structures existing already? Their performance. So that concept, there is one more concept called managed aquifer recharge. Artificial recharge and managed aquifer. Managed aquifer recharge is slightly different. You have to say include so many other parameters also. Then finally you can suggest new structures and you can identify the places. Of course, you have to consider you have to prepare all the maps, you can integrate using geospatial techniques, and finally you can identify the new structures for artificial recharge. Then here I want to tell you one important thing. Even most of the scientists or the professors, what they are doing is, when you talk about the artificial recharge, we will be concentrating more on the quantity of water. So how to improve the quantity of groundwater, right? So we will think in that way. But there is one more component normally the researchers will do. So we have to include the quality aspects also. Don't think that if you recharge the groundwater, the quality will improve. It is not always true. Please understand, in most of the cases it may be true. So if you recharge the groundwater, what will happen? Quantity will improve. You may think that it may dilute the concentration of ions in the water, but it is not the case in all the field scenario. This is not true. So that is why we have to do research in this particular field. So you have a lot of opportunities to do research. So you must understand the subsurface hydrogeochemical process. So what kind of mechanism is taking place in the aquifer system. So accordingly you have to suggest the sites. I think there are a lot of slides. I will quickly run the slides. Of course, we have done a study in Vattamalakkarai river basin. So Vattamalakkarai is one of the important tributary of Amaravati river. You know that Amaravati is one of the important tributaries of Kaveri. So it is in Kangayam area. Kangayam, it joins with Amaravati near, I think, in the Kangayam area. So this is the study area map. Of course, ground elevation model, surface runoff. Then this is about the status of fluoride. Fluoride is high there also, not only in Dharmaburi, Krishnagiri area. So here also the concentration of fluoride is more in open wells as well as in the bore wells. So we have to take pre-monsoon as well as post-monsoon. Then next important thing is nitrate. Nitrate is also very high in this area. We wondered really. You see the nitrate is 725 milligram per liter. Generally you can see this scenario in cities where the sewage is used there. So here this is a dry area. Nothing is there, no city, nothing. So but the concentration of nitrate was very high. Then we tried to identify the source. Yeah, source is this one. You will not believe this. Waste from the animals. Excreta of this animal. So that is the source. So first time we have reported this. Of course we have published this one. Because of this, the nitrate concentration is very high in that particular area. No other major source. Of course for fluoride and other things, there people are using fertilizers, right? But this is the source for that. So we have reported that. Then to identify the subsurface hydrogeochemical process, you can go for net path modeling. So like that there are so many other modeling techniques are available. It's related to quality, not related to flow or quantity. So net path modeling or pre-QC, there are so many modeling techniques available. So here you have to consider so many parameters. What is the thickness of topsoil? What is the thickness of weathered zone? All those things you have to consider. You have to consider the quality also. So wherever you will have black cotton soil, obviously the quality will be poor. All those things we have to bring into the account. Then fluctuation of groundwater. Of course, this is the subsurface lithology. So based on the borehole data, you can understand, and the fluctuation, minimum, maximum, summer, winter, everything you can plot. So all these things are very important if you do research. Then this is the flow direction, groundwater flow direction. Morning, Sivakumar sir was telling about the movement of water, like groundwater. So like surface water, groundwater will also move. It will move from the higher potentiometric level to the lower potentiometric level. Even many researchers are doing mistakes. So they will find out flow based on the water level. Water level is different, head is different. So water level is different, head is different. Water level means you are measuring the depth of water with respect to the ground surface. That is called water level. That is called water level. But head means with respect to some datum. Mostly our MSL. Mean sea level will be the datum. So what is the height of the water level or water table with respect to datum is known as head. So once you find out head, then only it is possible to find out the flow direction. Of course, it's a vector diagram. Vector diagram means both quantity and direction will be there. You can see the length of arrow will tell about the speed or velocity and direction. Both you can understand. These are all the well locations. So this is called groundwater table elevation model. Simply using GIS you can do. You need not go use MartFlow or GMS or AMS. Nothing is required. With the help of GIS you can do. Then you have to choose wells located in different geological formations as well as in different soil types, and you have to understand the mechanism. What kind of mechanism is going on. So whether ion exchange is there or reverse ion exchange is there or dissolution is there, dilution is there. So many mechanisms will take place, so you can predict. This model, this is the output of the model. Then I'll tell you, of course this one we can do. Normally we will do this. Even GIS will give. If you integrate various themes, finally if you ask your software, it will tell you where the potential will be more. Then you have to always validate your output. Many people are not doing this. You must validate your output. So simply you can validate with the help of water level. With the help of water level data, groundwater level data, you can update. You can validate your output. See here, this is the final 3D perspective view of this potential map. Of course, you can have categories, 3 categories or 4 categories. Low groundwater potential, moderate, high, very high, all those things you can have. Then finally, when you talk about artificial recharge, you are going to identify the location for constructing different artificial recharge structures like check dams, percolation ponds, recharge pits, injection wells and other things. So here you can see this area, we have identified some of the places for injection wells or recharge wells. So morning Sivakumar sir was telling about this clay. On the top you have clay layer. Particularly black cotton soil is available here. So porosity may be good and permeability may be very poor. So if you create percolation pond or if you put check dam, what will happen? So water will not percolate into the subsurface, it will go as evaporation. In those areas, you must go for this injection wells. Right? You have to send the water below the clay layer, then only the recharge will take place. So for that purpose only we have done this. Then what is new in this? Everybody is doing this. So what kind of research I can do, you can ask me, isn't it? So for that only you have come. So here, what will happen, I clearly told you, you should not suppose to consider only the porosity and permeability of the soil or formation to identify the location for recharge. You must consider the subsurface hydrogeochemical process or that mechanism. So if you don't want to do that, simply you can do this with field experiment. Field experiment means what? You can simply ask the farmers. They will simply tell. They may not be knowing anything about the subsurface hydrogeochemical process, but they will simply tell. If you ask the farmer, so what will happen after rain? Immediately he will tell, after rain, so water level will improve in my well, he will tell. Then you ask about quality. What will happen to the quality? One farmer will tell, yes, quantity is increasing. Water table is coming up, but at the same time, quality is getting deteriorated. Even if you go 1 kilometer away, so the scenario will be totally different. There, both quantity and quality will improve. Right? Because dilution is taking place. So this rainwater is diluting the groundwater. So the concentration of ions are getting reduced. So quality is improving, quantity is also improving. But in the first case, what happens? Dissolution is taking place. Dilution and dissolution. So dissolution means what will happen? Water table may be much below. When the rain occurs, this rainwater will dissolve the salts available in the weathered zone and it will add with the groundwater system. So that is why after rainfall, water quality will be poor. So if you identify those kind of areas for groundwater recharge, obviously it will improve the groundwater potential. What will happen to the quality? Yes, it will affect the quality. So you should not supposed to identify those areas for recharge. So this is the research, right? Then I think I have taken more time. Maybe quickly I will tell you this one more case study. So we have done this in the Tamarabarni Delta area. This is related to seawater intrusion. Of course, this work was done by 4 BE civil engineering students. You imagine, only 4 students, BE students, they have done this work. Then later on, I have converted it into a kind of thesis. So here, what happens, I will tell you the problem. This is the this Tamarabarni Delta, where the seawater is entering into the river channel during the high tide period, or gently, because the slope is very gentle here. So this seawater is entering into the river channels and it is polluting the groundwater, surface water, as well as the groundwater system. So here you see, this is a pumping station. So the people are taking water from this for their industry and drinking purpose. So there are so many industries located in this area. So they are concentrating on mining activity. Mining activity in the sense, they are taking the beach sand. So in beach sand, you have a lot of materials. Lot of valuable minerals are available in the beach sand in the form of monazite, in the form of ilmenite, in the form of rutile, in the form of zircon, in the form of magnetite. You have n number of minerals available in the beach sand. So they are processing the sand and they are separating the metals. For example, titanium. They are concentrating on titanium because rutile and ilmenite are the titanium ores. So these industries require huge quantity of water for ore beneficiation. So they are simply taking water from the Tamarabarni river. So what happens because of this seawater incursion, so this they are not able to directly use this water for their industrial needs. Of course, it is obvious that if the water is not suitable for industrial applications, that water cannot be used for drinking as well as for the irrigation. So what they have done, the farmers and the industry people, they have created a lot of temporary earthen bunds across these channels. So the pumping station is here. They are constructing these kind of temporary earthen bunds across all these channels to minimize the entry of seawater into, or the mixing of seawater into fresh water. If you take this one side you have seawater, the other side you have fresh water, river water. But the pathetic thing is, what will happen if the river carries more amount of water? All these bunds will be washed away. All the bunds will be pushed into sea. Then again they have to make bunds. Again all these materials will be pushed into sea. So they are not bringing any material from outside. They are simply dredging the sand available in the sea, river bed, and they are making these bunds. So knowingly or unknowingly, they are deepening the river channel. What will happen? So more amount of the seawater will enter into the system. So this is happening in this particular area. So of course, then one more important thing is salt pan. So the farmers are simply converting the agricultural land into salt pans because they are getting more money. We cannot blame them. They are getting more money. So you can see the agricultural land. They are simply converting the agricultural land into salt pans. To produce salt pan, they are not simply using the seawater. They are making borewell. They are taking the saline groundwater and they are producing salt. So because of this, more amount of seawater is entering into the subsurface also. Not only polluting the surface water, but also it is polluting the groundwater. You can see this is the last anaket constructed across the Tamarabarni river called Srivayundam anaket. And of course some canals are all there. Then we have conducted detailed study. You see this gentleman is measuring how much quantity of salt I can produce. Like milk, how much water will be there in milk, people will be testing. No, same way he is testing. And you see this fellow is using the groundwater for producing salt. And salt affected land you can see. And here one side you have seawater and another side you have river water. So we have measured what about the impact of seawater in this area. Then finally, based on all these things we have suggested, we have given a solution to construct a kind of weir, solid weir across the Tamarabarni river to minimize the seawater intrusion. So this is the plan view and sectional view of the weir. So we have given the design, then we have done the cost estimation also. Maybe after 10-15 years, now the government of Tamil Nadu is doing this work. They started constructing weir at almost in the same location with the same design parameters. So the Tamil Nadu government is doing this, you can see. Very recently we have not visited this area. I think the construction would have been over now. So this is the scenario. So I think I have taken more time. So half an hour was given. I think I have taken nearly 1 hour. So if you have any queries, please you can ask me, or you can interact with me if you have any doubts, queries. So groundwater means normally you will go for artificial recharge. Normally we will talk about the quality. But in the research institution, we will go one step say advanced to that. So that is research, isn't it? So in research means something new you should do. So if you have any doubts, please you can ask me. How many samples normally you will take, if it is a 500 square kilometer area, 500 square kilometer area normally will take around 40 samples, 40 to 50 samples will take, sir.
Okay.
If we have fund, we will take samples in 4 seasons.
Okay.
Pre-monsoon, post-monsoon, then summer and winter will take. Otherwise, we will take only 2 samples.
So 500 samples means how many
50,
days?
50 samples, yes.
50 sample analysis, how many parameters you will analysis? How many
Now,
days it will take?
yes. Now we have excellent facilities. Now we will test the samples for all the major ions and also minor and trace elements. We have ICBMS. It will give the results for 56 elements we can get. Now we have that facility. In olden days, what we will do, we will test for all the major ions and also fluoride and other things. That's all.
So 50 samples, how much time it will take for analyzing all the major ions?
Mostly they will do within 1 week or 2 weeks time. The research scholar will immediately complete the process.
Okay, thank you.
Any questions, queries, doubts or suggestions? Yes, micro.
At what rate that microplastic is affecting the recharge of that surface water?
Microplastic will not affect the recharge because it's a very little or very tiny particle. That's why it's micro or it is nano. It is not going to affect the recharge mechanism. So it is a kind of one of the components in the water. It will not affect the recharge. It will not affect the recharge, but what happens, so now the microplastic content is more in surface water, very less in groundwater, I can say. Only the shallow aquifer is having these microplastics. Shallow wells are having microplastics, but if you test the borewell water, microplastics may not be there. But maybe after, I can say 5 years, we do not know. If you don't control, even deep wells will also have microplastic. Because it's a very tiny, little particle, it can very easily go along with water. Some extent, it can be filtered by the soil media. Otherwise, it will go along with water. Definitely, it is going to contaminate. It will not affect the recharge. It is not going to affect the recharge.
Regarding this recharge studies, when we talk about groundwater recharge, we just talk about the recharge. But I find that we forget about the surface water that is needed for that watershed or catchment to carry. So how this aspect has been considered so far? In the sense, whether we are completely disregarding the importance of surface water while we talk about recharge, groundwater recharge.
So we don't have enough surface water. If we have enough surface water, we need not bother about this artificial recharge. We don't have enough surface water to meet out our day-to-day activities. That is why we are seeing the groundwater. So in general, if you talk about the quality point of view, generally groundwater will have better quality when compared with the surface water. Surface water can be easily polluted when compared with the groundwater because it is far away from the source of pollution. So this is one aspect. So we need to use groundwater for our various activities. So that is why we have to take out groundwater. So if you continuously take out the groundwater, and of course this recharge and discharge are not matching, then water table will slowly it will go down. But olden days, our great people, world people, they have created so many ponds, they have created so many tanks and all in temples and other places to recharge this groundwater. But now what happens, even if you take the Chennai city, if you take the topo sheets prepared by the British people, you can see lot of lakes or tanks. Now all the lakes are completely occupied. Now you can see the concrete jungle. So this concrete jungle will not allow the water to percolate down. So you have to make provision to allow the water to percolate down. So for that purpose only we are doing this artificial recharge. And of course I will tell you one more important concept to all of you. So whenever there is a good amount of rainfall, whenever there is a huge water flow in the river, so the particularly people, politicians, they will tell that we should not supposed to waste the water. So this much quantity of water has reached sea. We have wasted. It's not like that. If you stop this discharge, suppose single drop of water is not reaching sea, what will happen? Suppose you are not allowing the water to reach sea. No single drop of water is reaching sea. What will happen? Entire system will be collapsed. Entire system will be collapsed. So there may be lot of negative impacts also. If you construct artificial recharge structures, definitely negative impacts will also be there. One example I will tell you, if you construct check dams every 1 kilometer across the river channel, what will happen? Definitely recharge will take place. What about the formation of sand? Sand will not form. How sand will form? So initially it will be a huge boulder in the upstream side, in the hilly areas. Then it will be rolled down. It will be pushed further. Then in the upstream, say in Kodagu, so the size of the particle will be huge, like a boulder. Then it will be a cobble, then pebble, then it will be a gravel, then sand, silt, clay. Finally, if you go to this deltaic area, you will find only clay or silt. Say if you go to Tanjore Delta, you will find only clay and silt. In say Tiruchirappalli, you will have sand, right? In Mettur area, size of the grains will be more. But if you construct lot of check dams, what will happen? Sand formation will not take place. And of course, sand mining is also going on parallelly. And finally, what will happen? Sand will not be there in riverbeds. So we must be very careful. So whatever we do, even agriculture itself will pollute, it will create a lot of issues. It's not a natural. Don't think that agriculture is a natural thing. No. Agriculture itself is artificial. Okay. So everything will have some impact.
Sir?
Yeah.
Sir, you told that THI, total hazard index, sir.
Yes.
How do we calculate that total hazard index, and what are all the parameters to use for the total hazard index, sir?
Yes, for total hazard, I will give you the papers. You can refer my papers. There are some equations. There are some formula. You have to use those formula to find out what is that HQ, hazard quotient.
Okay,
so
sir.
there are so many parameters. Say what is the concentration of a particular, for example, you are working with fluoride. What is the concentration of fluoride? Then what about the body weight? How long you are going to consume? Right? Then all the things, how much quantity you are going to consume. So everything is there.
Okay, sir.
So based on that you will calculate HQ, oral. Right? Dermal means you are taking bath. So water is touching our skin. So through skin also it can enter. So you have to calculate HQ for dermal, and if you add both, you will get total hazard index. It should be less than 1.
Okay,
it should
sir.
be less than 1.
Less than 1.
Yeah.
Okay, sir. Thank you, sir.
So for various, say water quality parameters you can do. For fluoride you can do, for nitrate you can do, for chromium you can do, like that you can do.
Okay, sir. They allow of the specific standards in total hazard index.
There are some.
Specific permissible limit in total hazard index separately compare with who are BIS.
Yeah, say US, United States Environmental Protection Agency is giving some guidelines. WHO is giving guidelines. We have to follow all those things. So
Okay.
based on that only you can get the results.
Thank you, sir. Thank you, sir.
Sir, my question is, today many villages are dependent on the shallow dug wells for drinking water.
Yes.
So at village level, how can these microplastics can be removed? Is there any economic
Yeah, very simple. Yeah, your question is a very good question.
home level and at village level?
Yes, village level, how to remove the microplastics is a very good question. So very simple, if you have RO, it will remove microplastics.
Village level?
Yeah, in village level, if you use RO, almost nowadays in village also they are using RO, reverse osmosis, small one.
Those who are not afford of?
You have to consume, no other way. You cannot remove. Even this sand filter will not remove. Sediment filter, you will have sediment filter. Sediment filter will not remove.
Normal
Carbon
filter
will not remove. If you go for RO system, then only it will remove.
Okay. Even nanoplastic also.
Yeah, nanoplastic, I do not know about the nanoplastic. It will be removed definitely if you use RO, because it can remove salt, no? Size of the salt, when compared with the size of, it may be very salt size will be even less than the size of the microplastics. Yeah, RO will work. RO will remove.
Okay.
We have tested RO water also. We have tested RO water. We have tested filters without RO. So in many houses, even in Chennai, we have UV filters. You will have one sand filter, sediment filter, then carbon filter will be there, then UV will be there. There won't be any this RO.
Okay.
So in that case, microplastics is there.
So it
We
will
have
be
tested
removed.
that also.
Okay. Thank you.
RO water is good or not? It's a very big question. RO water is, some case it is yes, some case no. For example, if your TDS is more, suppose your TDS is 1500 or say 1200, in that case if you put RO, it may be good. It may be good. If your say TDS of the water or groundwater is say 500 or 400, if you put RO, what will happen? Nothing will be there in your water. TDS will be very less. The water will be like a distilled water. You should not supposed to consume distilled water. So before putting RO, you must at least test what is the TDS of the water. If the TDS of water is more than say 1000, you can put. If it is less than 1000, you please avoid RO. If you put RO, it will remove all the salts completely. Nothing will be there. So it will definitely, it is going to affect the complete system, particularly children. Don't give it to children. So if they consume water continuously, they will be sick. It will affect the entire system. It will affect the entire system, brain, nervous system. It will collapse everything. Nothing will be there. So that's the problem. That's the problem. So even if you test the bottles, water bottles, the salt content will be very, very less. Sometimes TDS may be 20 or 30. You should not supposed to consume the water. So at least 200, 250 should be there. At least 250 should be there. Simple example, you go to some falls, waterfalls in hilly area, you take the sample and you test, that is a good water. If you taste the water which is coming in the Kutralam falls or Panadirtham, it's called Panadirtham. You take that water and you test in the laboratory, TDS will be around 200. So that water is good for our health. That water is up to 1000 we can have. If it goes beyond 1000, it is called brackish water. Brackish water nu solluvom. Saline water nu solla matom. Adukku mela pona da saline. Adukapram brain water nu solluvom. Brackish water நிறைய இடத்துல கிணறுல இருக்கும். See நான் இந்த மெக்கானிசம் சொன்னேன் உங்களுக்கு பாத்தீங்கன்னா அந்த dissolution and dilution mechanism உங்களுக்கு சொன்னேன். ஸோ அங்கே இருக்கிற விவசாயிகிட்ட கேட்டிங்கன்னாவே சொல்லிடுவாங்க. ரெண்டாவது நீங்கள் ஃபீல்டுக்கு போனால் தான் தெரியும். நிறைய விஷயம் வந்து நம்ம இன்ஸ்ட்ருமெண்ட் வச்சு டெஸ்ட் பண்ணவே தேவையில்லை. முன்னாடிலாம் டாக்டர்ஸ் இப்படி பார்த்துட்டு சொல்லிடுவாங்க. இன்றைக்கி எது எடுத்தாலும் we are depending on the machine. எது எடுத்தாலும் மெஷினை தான் டிபெண்ட் பண்ணுறோம். ஒன்றும் இல்லை, நீங்கள் ஒரு ஏரியாவுக்கு போகிறீங்க அப்படின்னா அந்த ஏரியாவில் இருக்கிற தண்ணியை குடிச்சு பார்க்காமலே அந்த ஏரியாவில் இருக்கிற தண்ணி எப்படி இருக்குன்னு ஓரளவுக்கு கெஸ் பண்ணலாம். ஃபார் எக்ஸாம்பிள், ஒரு ஏரியாவில் பார்த்தீங்க அப்படின்னா நல்ல பயிர், சோளம் அந்த மாதிரி பயிரெலாம் அழகாக வச்சுருப்பாங்க. அதே ஒரு 1/2 கிலோமீட்டர் 1 கிலோமீட்டர் தள்ளி வந்தீங்க அப்படின்னா அங்கே கிராப்பே வேறு மாதிரி இருக்கும். ராகி இருக்கும், பருத்தி செடி இருக்கும், காட்டன் இருக்கும். அப்போவே நீங்கள் புரிஞ்சுக்கலாம் அந்த இடத்துல தண்ணி வந்து பிராக்கிஷ் வாட்டர். கண்டிப்பாக அந்த இடத்துல இருக்கிற ஒரு வெள்ளில் போய் தண்ணி எடுத்து டெஸ்ட் பண்ணி பார்த்தீங்கன்னா 1000 TDS கூட அதிகமாக இருக்கும். அதனால தான் அவங்க என்ன பண்ணுறாங்க, அதே மாதிரி சாயில் பார்த்தீங்க அப்படின்னா அங்கே பார்த்தீங்கன்னா ரெட் சாயிலாக இருக்கும், இங்கே பார்த்தீங்கன்னா பிளாக் கலரில் இருக்கும். ஸோ அந்த பிளாக் கலர் சாயிலுக்கும் பிராக்கிஷ் வாட்டருக்கும் பருத்தி தான் வரும், இல்லைன்னா கேழ்வரகு தான் வரும். பார்த்தோன்னே நீங்கள் சொல்லிடலாம், நீங்கள் டெஸ்ட் கூட பண்ண தேவையில்லை. ஸோ அதனால் ஃபீல்டு நாலேஜ் வந்து ரொம்ப ரொம்ப இம்பார்ட்டன்ட். ஸோ அப்போ நம்ம ஃபீல்டு ஒர்க் போகும்போது அங்கே இருக்கிற ஃபார்மர்ஸ்கிட்ட கண்டிப்பாக நீங்கள் கேட்கணும். கேட்டிங்கனாவே இந்த மெக்கானிசம்லாம் சொல்லிடுவாங்க. டைல்யூஷன் நடக்குதா, டிசல்யூஷன் நடக்குதா அப்படிங்கிறது எல்லாமே உங்களுக்கு தெரிஞ்சிடும். டிசல்யூஷனாக என்ன ஆகும்னா, வாட்டர் டேபிள் மேலே இருக்கும்போது அதில் இருக்கிற சால்ட் வந்து அப்படியே கொஞ்சம் கொஞ்சமாக டெபாசிட் ஆக ஆரம்பிச்சிடும், வாட்டர் டேபிள் கீழே போயிடும். திரும்ப மழை பெய்யும் போது என்ன ஆகும் அப்படின்னா, அந்த மழை தண்ணியில் அந்த சால்ட்னா சோடியம் குளோரைடாக இருக்கும், ஹேலைட்டாக இருக்கும், அது அப்படியே கரைஞ்சி போய் திரும்ப ரீசார்ஜ் பண்ணும்போது குவாலிட்டியும் சேர்த்துக்கு எடுத்துட்டோம். குவான்டிட்டி இம்ப்ரூவ் ஆகும், குவாலிட்டி மோசமாகிடும். ஓகே, அதை தான் நம்ம இங்கே வந்து சயின்டிஃபிக்காக ரிவர்ஸ் அயான் எக்ஸ்சேஞ்ச் நடக்குது, அயான் எக்ஸ்சேஞ்ச் நடக்குது, சிலிகேட் வெதரிங் நடக்குது, கார்பனேட் டிசல்யூஷன் நடக்குது, எவாப்ரேஷன் எல்லாமே அதை குவான்டிஃபை பண்ணி சொல்கிறோம். பட் ஃபார்மர்ஸ் வந்து அவங்களுக்கு என்ன நடக்குதுன்னு தெரியாது, ஆனால் சொல்லிடுவாங்க. ஸோ இந்த மாதிரியான ஆஸ்பெக்ட்ஸ் வந்து நம்ம ஃபீல்டில் நம்ம சாம்பிள்லாம் கலெக்ட் பண்ண போகும்போது இதெல்லாம் கேர்ஃபுல்லாக நம்ம பார்க்கணும். அதே மாதிரி நிறைய இடத்துல அந்த ரேடியேஷன் அவங்களுக்கு சொன்னேன். ஸோ நீங்கள் ஃபார்மர்ஸ் அவங்க ஏதோ சம் ஸ்டோரி சொல்லுவாங்க, பட் அதனோட இம்பாக்ட் இருக்கும். நான் ஒரு சில இதெல்லாம் ஃபோட்டோ எடுக்க விட மாட்டாங்க. ஸ்கெலிட்டல் ஃப்ளோரஸ்லாம் பார்த்தீங்கன்னா குழந்தைங்களை அப்படியே தூக்கிட்டு போய் ஸ்கூலில் வச்சு தூக்கிட்டு வராங்க, ஃபோட்டோலாம் எடுக்க விட மாட்டாங்க. ஸோ அந்த மாதிரிலாம் உங்களுக்கு இருக்குது. ரேடியேஷன் அப்படின்னா பார்த்தீங்கன்னா ஒரு சில ஏரியாவில் பார்த்தீங்கன்னா நிறைய ஆஸ்மா ட்ரபிள், வீசிங் ப்ராப்ளம் இருக்கும். அதுக்கு அடுத்த ஸ்டேஜ் போச்சுன்னா தான் உங்களுக்கு கேன்சர் ரிஸ்க் வந்து அதிகமாக இருக்கும். ஏன்னா உங்களுக்கு யுரேனியம் கண்டென்ட் வந்து 300க்கு மேலே போச்சு அப்படின்னா கண்டிப்பாக ரிஸ்க் தான். ஸோ அந்த மாதிரி இருக்கும். ஒரு சில இடத்துல அவங்கள்ட்ட கேட்டால் சொல்லுவாங்க. ஒரு இடத்துல பார்த்தீங்கன்னா அந்த சென்டிலோமீட்டர் 1 மீட்டர் ஹைட்டுக்கு இப்படி பிடிச்சும் போது பார்த்தீங்கன்னா நல்ல ரேடியேஷன் காட்டுது. அந்த ராக் எக்ஸ்போசர் மேலேயே வீடு கட்டியிருக்காங்க. அவங்களுக்கு தெரியாது. பட் நீங்கள் அவங்களை கேட்டிங்கன்னா என்ன சொல்லுவாங்க, சரியாக தூக்கம் வர மாட்டேங்குது. என்னன்னு கேட்டால் பழைய கதை சொல்லுவாங்க. ஏதோ சாபம் விட்டாங்க, அந்த காலத்தில் சண்டை தகராறு அந்த மாதிரி ஏதாவது சொல்லுவாங்க. ஒரு சில ஏரியாவில் நீங்கள் நொய்யல் அந்த ஏரியாலாம் போனீங்க அப்படின்னா ஆடு வந்து குட்டி போடாது, மலடாகவே இருக்கும். நிறைய பாருங்கள், நிறைய பேருக்கு குழந்தை இருக்காது, நிறைய இஷ்யூஸ்லாம் இருக்குது. ஒரு சில இடத்துல இன்னும் பேத்தட்டிக்காக இருக்குது, சொல்லவே முடியாது. ரைட்டா? நம்ம காலையில் நம்ம வைஸ் சான்சலர் கூட சொல்லியிருந்தார், ரிசல்ட் ஜீரோ லிக்விட் டிஸ்சார்ஜ் எல்லாம் நம்ம சொல்கிறோம். பட் சம்டைம்ஸ் வந்து நம்ம தான் மிஸ்டேக் பண்ணுறோம். ஸோ நம்ம வேஸ்ட்டை வந்து டிஸ்சார்ஜ் பண்ணக்கூடாது, எஃப்ளூயண்ட்டை டிஸ்சார்ஜ் பண்ணக்கூடாது சொல்கிறோம். எங்கே டிஸ்சார்ஜ் பண்ணக்கூடாதுன்னு சொல்கிறாங்க? ரிவரில் டிஸ்சார்ஜ் பண்ண வேண்டாம். சரி, நான் போர்வெல் இருக்குது, ஒரு போரை போட்டு போர்வெல்லில் டிஸ்சார்ஜ் பண்ணுறாரு ஒருத்தர். என்ன பண்ணுறது? போரை போட்டு மனசாட்சியே இல்லாமல் போருக்குள்ளே வந்து சாய தண்ணியை விட்டால் என்ன ஆகும்? பக்கத்தில் ஏரியா எல்லாத்தையும் அஃபெக்ட் ஆகிரும். அவரும் தான் குடிப்பார், அவங்க குழந்தைங்களும் தான் குடிக்கும். ஸோ இதெல்லாம் மனசாட்சியே இல்லாமல் நம்ம பண்ணும்போது, ஸோ பட்டுக்கோட்டை சொல்கிற மாதிரி தான். என்ன சொல்கிறது? சட்டம் போட்டு தடுக்கிற கூட்டம் தடுத்துக்கிட்டே இருக்குது, திட்டம் போட்டு திருடுற கூட்டம் திருடி தான் இருக்குது. அது அந்த மாதிரி நம்மளாக பார்த்து ஒவ்வொருத்தராக ஒரு பண்ணலை அப்படின்னா ஸோ என்ன தான் நம்ம சொன்னாலும் பண்ண முடியாது. அதே மாதிரி இப்போது தண்ணி எடுத்தோம் அப்படின்னா டேக்ஸ் போடணும், வாட்டர் ஆக்ட் போடணும், எல்லாம் போடணும், எல்லாம் சொல்கிறோம். பட் ப்ராக்டிக்கலாக பாருங்கள், அது கண்டிப்பாக வேணும், கண்டிப்பாக வேணும். நீங்கள் நம்ம தமிழ்நாடு எடுத்துக்கோங்க, எந்த ஒரு கண்ட்ரோல் ரெஸ்ட்ரிக்ஷன் எதுவுமே கிடையாது. நான் என்னோடய ஃபீல்டு இருக்குது, 100 போர்வெல் போடணுமா போட்டுக்கலாம், 1500 அடி போடணுமா எஸ் போட்டுக்கலாம். என்ன கண்ட்ரோல் இருக்குது? எதுவுமே இருக்காது. ஸோ நீங்கள் ஒன்றும் இல்லை, நீங்கள் சென்னை சிட்டி மட்டும் எடுத்துக்கோங்க. நான் நிறைய இடத்துல சொல்கிறது உண்டு. சென்னை சிட்டி மட்டும் எடுத்துக்கங்க, இருக்கிற வெல்ஸ், போர்வெல்ஸ் லொக்கேஷனை மட்டும் அப்படியே பிளாட் பண்ணுங்கள். இல்லை ஒரு ஏரியல் வியூவிலேருந்து பாருங்கள், என்டையர் சென்னை வந்து ஓட்டையாக தான் இருக்கும், கம்ப்ளீட்டாக ஓட்டை. ஒவ்வொரு வீட்டுக்கும் எத்தனை ஓட்டை இருக்குது, எத்தனை போர்வெல் இருக்குது. இதைத்தான் நம்ம அடுத்த ஜென்ரேஷன் விட்டுட்டு போகிறோம். இன்னொரு சயின்டிஸ்ட் சொன்னார், இது மட்டும் விட்டுட்டு போகல, செப்டிக் டேங்கையும் சேர்த்து விட்டுட்டு போகிறோங்கிறாரு. எல்லா இடத்துலையும் செப்டிக் டேங்க் கட்டி விட்டோம், போயிட்டோம். இதுதான் நம்ம நெக்ஸ்ட் ஜென்ரேஷன் விட்டுட்டு போகிறோம். இதுதான் வந்து பேத்தட்டிக் திங். கம்ப்ளீட்டாக ஓட்டை போட்டோம், எர்த்தை ஏகப்பட்ட ஓட்டை போட்டு வச்சிட்டோம். அப்புறம் என்ன சொல்கிறது? ஸோ இதுதான் வந்து பெரிய ப்ராப்ளம். ஸோ இது ஒவ்வொருத்தராக நம்ம இதுக்கு ஒரு பிளான் பண்ணி பண்ணல அப்படின்னா இதுக்கு எந்த ஒரு சொல்யூஷனுமே கிடையாது. ஸோ சென்ட்ரல் கிரவுண்ட் வாட்டர் போர்டோ இல்லை கவர்மெண்ட்டோ நம்ம ரிசர்ச் பண்ணுவோம், அவங்க ஒரு பண்ணுவாங்க. பட் கம்ப்ளீட்டாக வந்து ரெமெடி கொடுக்க முடியாதுன்னு தான் எனக்கு தோணுது. கஷ்டம்தான். ஸோ அந்த மாதிரி. பட் உங்களுக்கு ரீசார்ஜ் பண்ணிட்டோம் அப்படின்னா வாட்டர் ஆக்ட் எதுவுமே தேவையில்லை. வித்ட்ரா பண்ணுற அளவுக்கு நம்ம ரீசார்ஜ் பண்ணிட்டோம். அஃப்கோர்ஸ் ட்ரவுட் வரதான் செய்யும், வரலன்னா அப்புறம் பூமியே கிடையாது. சரி, எர்த்குவேக் வரலன்னா பூமியே கிடையாது, அது புரிஞ்சுக்கணும். நிலநடுக்கம்ங்கிறது ஒன்று இல்லைன்னு வச்சுக்கோங்க, பூமி உயிரோடு இருக்காது. பூமி உயிரோடு இருந்தால் தான் நம்ம உயிரோடு இருக்க முடியும். எர்த்குவேக் யாரையும் கொள்ளாது, இந்த பில்டிங் நம்ம கட்டி வச்சுருக்கதான் நம்மளை கொல்லும். எர்த்தும் ஆக்டிவாக இருக்கணும். எந்த மாதிரி ஆக்டிவாக இருக்குது? எர்த்குவேக் மாதிரி வல்கேனோ மாதிரி இருந்தால் தான் ஆக்டிவாக இருக்கும். ஸோ அந்த மாதிரி இருக்கும்போது நேச்சுரலாகவே ரீசார்ஜ் நடந்துகிட்டே இருக்கும், நம்ம வித்ட்ரா பண்ணிகிட்டே இருக்கோம். ரெண்டும் பேலன்ஸாக இருந்ததுன்னா பிரச்சனை கிடையாது. ஓகே, அது ஒன்று. 2 எக்ஸஸாக நீங்கள் ரீசார்ஜ் பண்ணாலும் அது கடலுக்கு போயிருக்கும், நிற்காது. சப்போஸ் இந்த வருஷம் நல்ல மழை பெஞ்சுது, நிறைய ரீசார்ஜ் பண்ணிட்டோம் அப்படின்னு விட்டுட்டா நிற்கும்னு நினைக்கிறீங்களா? நாமக்கல்லில் ரீசார்ஜ் எக்ஸஸாக பண்ணிங்கனாலும் அது கடலுக்கு போயிடும். எப்படி சர்ஃபேஸ் வாட்டர் போகுதோ அதே மாதிரி கிரவுண்டுக்குள்ளேயும் போயிடும். ரைட்டா? எக்ஸஸ் வாட்டர் நேச்சுரலாகவே கடலில் டிஸ்சார்ஜ் ஆகும். வாட்டர் டேபிள் வந்து வாட்டர் லெவலில் மேலே போச்சுன்னா எல்லாமே கனெக்டட் தான் போயிடும். அதனால் நம்ம ஒரு டைம் ரீசார்ஜ் பண்ணிட்டா நின்றுக்குன்னு கிடையாது. இது வந்து கண்டினியூஸ் மெக்கானிசம், இது நடந்துகிட்டே தான் இருக்கும். ஸோ அதை வந்து நம்ம டேக் கேர் பண்ணிட்டா போதும்.